in this chapter, the goal is for us to be able to say that I can find the distance between 2 points. We aren't going to make it all the way through this chapter today, but we are going to finish it up tomorrow. So for today, we're just going to at least start the conversation. Before we actually start the conversation with that, I do want to clarify some key words that we are going to have throughout this school year. And we want to be able to understand what these mean. So one thing that I want to make sure we understand is the difference between an undefined term, a postulate, a definition, a conjecture, and then theorems. These are going to be things or words that I say throughout this school year that we need to make sure we understand the difference between the two, or between the items. We've already talked about undefined terms. Remember, these were things like points, lines, and planes. Okay? Then postulates takes it a step further. Postulates are things that we assume, these are things that we assume to be true. And this is without proof. Well, you may be wondering, well, that sounds a lot like undefined terms. So what's the main difference between undefined terms? The main difference between undefined terms is that undefined terms are basic ideas. They are objects in geometry. A point is an object. A line is an object. A plane is an object. A postulate is a basic truth that we know is true. It's a rule that we know is true. So that's the main difference. One is talking more about objects. The other one is talking about truths, basic truths. So now we are going to talk about definitions. Okay, these are a clear sentence that describes a term. So it's a clear sentence that describes a term. These, we are going to have a lot of definitions as time goes on. So make sure you are paying attention to those. A conjecture. A conjecture is something that we think is true. We think true, but we don't have a proof for it. Or we don't have proof. Okay, so postulate are things that we assume to be true. Okay, so we assume it to be true. A conjecture is something that we think is true but don't have a proof. Postulates we don't have to prove. These are our assumptions, our basic truths that we are not going to need to prove either. Okay, theorems are some things. It's something that we prove, something that we show has to be true. Okay, so far, all these things do not really have to be proved. A definition does not have to be proved. A postulate doesn't have to be proved. Undefined terms don't have to be proved. Conjectures do not have to be proved. Theorems, these are things that are proved to be true and proved to be true all the time. The theorems are things that are proven to be true. And you guys are going to learn about proofs as the semester goes on. So that is just some key words. Make sure you understand what each of these mean as the time goes on. again, I'm just going to do a quick review over some stuff that we talked about. A point, you guys all know what a point is. It's a little speck. It has no dimensions. We typically say we have point P, we have point A. We could label our points. We have a line. Remember, we have line. We have an infinite amount of points on this line. We could say that this is line AB. Line segments. These are similar to lines, except lines go on forever in either direction. Okay? They go on forever. Remember, lines are one-dimensional. They go on forever in both of in that one dimension. Line segments, these actually have length. They have a measurement. And the way we indicate a line segment is we don't use the arrows, but we kind of just put dots at the end of those. Okay? And we label the ends as, we can say, AB. So that's a line segment. It has a beginning and it has an end. A line has no beginning and no end, but a line segment does. It has both a beginning and an end. And the way we notate a line segment is, it's just like the line, except we don't put the arrows on the end. Okay, so we put a line over top without the arrows. So that's why it's a line segment. We could also talk about it by saying line segment AB, or whatever the name of the line segment is. So I mentioned that line segments have length. This brings us to what's called the segment addition postulate. Okay, the segment addition postulate. And remember what a postulate is. A postulate are things that we assume to be true without proof. Okay, so here's what it says. If we have a segment, a line segment, and we have 3 points, they are collinear, right? Let's say we have point A, point B, point C, where B is between A and C, okay? By the way, whenever you say between 2 points, it is assumed to be collinear, meaning it lies on the same line, okay? So the segment addition postulate basically says, well, right here we have 2 segments. We have segment AB, which has a length, and we have a segment that is BC that has a length, right? What we can do is we can add these 2 segments, and whenever we talk about a specific length, we no longer need the line over top, okay? Because it's assumed we are talking about the length of the segment, okay? So if we put an addition, don't put the line over top. If we can add these 2 segments together and end up with the total segment, okay? So we can end up with just segment AC, okay? So we can have segment AB plus segment BC, that equals to the total length of the total segment. Not very groundbreaking. This is something that is so easy to see that we don't need a proof. That's why it's called a postulate. Another word for postulate could be an axiom, okay? So we have AB plus BC equals to the total length. 2 segments added together equals to the total length. That's what the segment addition postulate basically says. Okay, let's look at an example. Find each measure. Assume that the figures are not drawn to scale. Okay, so we are assuming that they are not drawn to scale. So we have segment AB, which is 1/3 inch. We have segment BC, which is 3 1/4 inch. Again, not drawn to scale. Okay, so it's not accurate on the actual inches. These are just an example, a visualization of what's going on. So remember, add 2 segments together to get the big segment. We want to know what is the length from A all the way to C. So we need to add AB plus BC together. So all we had to do, let's just write this down. AC equals to AB plus BC. We know that A to B is 1/3. we know that b to c is 3 1/4. Okay, so from here, how do we add fractions? Remember, adding fractions, we had to have the same basis. We had to have the same denominator. But before we do that, we need to make sure that we have them as improper fractions. So make this an improper fraction. This is 1/3 plus, okay, so we go 3 times 4, the number on the side times the base, so 3 times 4 is 12. Add that to the numerator, so this would be 13/4. Same base, the smallest base is 12, which is 3 times 4. So in order to get 12 on both of them, we end up multiplying by 4/4 on the first one and 3/3 on the second one. Remember, whatever you do to the bottom of the fraction, we have to do it to the top, so that we end up with 4/12 plus, okay, 3 times 13 is 39/12. Adding those together, 4 plus 39 is 43/12. Okay, but let's put it back into a mixed number, put it back into the proper fraction format. All right, so let's go 43 divided by 12, 12 into 43. That will end up to be not 4, but actually 3 times. So this is 36. Subtract. We had to borrow. This would be 3. That would be 13. 13 minus by 6 is going to end up to be 7. 3 minus 3 is nothing. All right. So in other words, it goes into it 3 times with 7 remaining and 12 as our bottom on the fraction, as a denominator. And that is how many inches across, this line is. It's 3 7/12 of an inch. Remember, adding the two segments together to equal the large segment. Here's another example. In this example, we are looking for the length of DE. However, DE is not the total length of this line. It's a small section of the line. So we can say DE plus the other segment, EF, is going to equal the total segment, which is DF. Remember, adding two segments together equals a larger segment. Plugging the numbers in, we have no idea what DE is, so we had to find it. So DE plus EF is 5.1 equals to DF, which is 7.2. Okay, get DE by itself. We are going to use a little bit of our Algebra 1 skills. So we end up remembering how to solve an equation. We subtract by 5.1 on both sides. Remember, we want to move the item that is over there with the unknown. So we end up with DE equals 2 minus by 1 gives us 1. 7 minus by 5 gives us 2 to 2.1. And this is going to be in centimeters. And that is the answer to this problem. Remember, the segments added together equals a larger segment. That's the segment addition postulate. You need to remember that postulate because you are going to end up using it later on. So that's that first type of example. Another type of example, they are not going to give you the nice picture. Unfortunately, they will not give you the nice picture all the time. So they are going to end up describing what is going on. Find the value of x and mn. That's segment mn. Notice it doesn't have the arrows on both sides, so this is talking about a line segment mn. M and n. If m is between points n and L, m to n is 6x minus 1, L to n is 15, and L to m is 2x. Notice, whenever they are talking about the segment, the line segment in general, we put a line over it without arrows. Whenever you're talking about a specific length, we put no line. Okay, so make sure you know the difference so that whenever you're writing your homework, you don't accidentally put the line or accidentally not putting the line. We need to know when to use it, when not to use it. Okay, so let's draw a picture. Let's go ahead and make ourselves a line segment. We have a line segment here. We know that M is between the points N and L. That means N and L are on the edges. N and L are on the sides. And M is somewhere between. By being between, it is assumed to be collinear. We don't have to make it to scale. We can just put it anywhere on this line. Let's put point M. Let's put point M maybe over here. Okay, it doesn't matter where we put it. Yes, in the end, we would want to fix up our scale, fix up our model. But for the sake of drawing it, for the sake of figuring out this problem, and just figuring out how to set up our equation, we don't have to. We don't have to worry about where it goes. Okay, so we know M to N is 6x minus 1. The length of this is 6x minus 1. We know L to N is 15. So that's this total length right here. This is 15. 15 inches, 15 centimeters, is 15 something. And L to M is 2x. Remember, segment addition postulate, two segments added together equals a larger segment. So we are going to make an equation. We have 6x minus 1. That's this first segment. That's M to N. We have the second segment, which is 2x. So we are going to add 2x to this. And that is going to be equal to that 15. Let me just spell out what we did. We have MN plus ML equals to N to L. Okay? Notice MN is the one to the left. ML is the other smaller segment equals a larger segment. Two smaller segments equals a larger segment. All right, now we just have to solve for x. Gather like terms. Remember your Algebra 1 skills. 6x plus 2x is 8x equals to 15. Get x alone, so we are going to end up doing the opposite of minus 1. So we add 1, add 1. So we have 8x equals to 16. Divide by 8, so x is equal to 2. That is the first part of this question. Find the value of x. It is 2. Make sure you read all of it. It also says find the value of M to N, the length of the segment. Find how long it is. So M to N is this 6x minus 1, right? We know the x value is 2, so now we just have to plug in. 2 times 6 minus by 1 gives us 12 minus by 1, which gives us 11. So the length of MN equals to 11. Okay? Notice whenever I write the length of it, I don't put the line over top. If I'm talking about the line segment in general, we put the line over top. If I'm talking about a specific length, I don't have to put the line over top. Okay? Here's another example. Again, there is no there is no picture of this. So let's draw a picture. So let's just make ourselves a line segment. And let's put some things on this. Let's just put the third dot right here. Doesn't matter where you put it, because we're just trying to get a visual representation. Here's a question. Find the value of A and set line segment XY if Z is between points X and Y and XZ equals 15, ZY equals to 2, that's supposed to be 2A plus 1, and XY is 3A. Okay, the X's I put in the equation, I messed up. I need to make sure I fix that for next time around. So we know Z is between X and Y. Between means that they are collinear and that it is between those other two. So let's put X and Y on the ends, and Z is somewhere between. Somewhere on that line segment, somewhere between those values. We know that X to Z is 15. We know X to Z to Y is 2A plus 1. And we also know that X to Y is 3A. Okay. Segment addition postulate. Add the 2 up, so this is 15 plus 2a plus 1 equals to 3a. By the way, this is going to be xz. This would be zy equals to xy, right? The 2 smaller segments added together equals a larger segment. Okay, algebra skills. So all we have to do now, subtract our 2a on both sides, subtract 2a, get those terms together. So we have 15 plus 1 equals to a. 15 plus 1 is 16, which equals a. That's the value of a. First part of this question, done. Second part, find xy, the length of this line segment. Okay, x to y is the total length. Total length is 3a, isn't it? Yeah. A is 16, so this is 3 times 16. 3 times 16, let's go ahead and just do that over here. 3 times 6 gives us 18. 3 times 1 is 3 plus 1 is 4. So this would be 48. So the length of x to y equals 48. Just a few more things before we end class today. I want to talk a little bit about what it means to be congruent or congruency. I'm going to talk a little bit about congruent segments. We are almost done. So, congruence. Congruency is whenever we have 2 objects, 2 shapes that are exactly the same. Okay? This is when make sure I spell it correct. When the objects or shapes are the same. Okay, it's similar to equals. It's similar whenever we say equals. And I'll explain the difference between equals and congruence in just a moment. Congruent segment. Before I talk about congruent segment, this is how we show congruence. This is a symbol. We use the equals to sign and put a little squiggly line over top. This means congruence. It means 2 things are congruent to each other. Congruent segments. 2 segments are congruent if they have the same length. Okay? So we say 2 segments are congruent if they have the same length. Okay, so here's how we would write it. If we wanted to write a shorthand way of saying that 2 things are congruent, let's assume that we have 2 line segments. Okay, let's say we have this line segment, and let's say we have this other line segment. If they have the same length, we can indicate by a little tick mark across the line segment. Let's say that these are congruent. Let's say that the first line segment is AB, and let's say the last one is XY. This is how we would say it shorthand. We would be able to say that AB line segment is congruent to line segment XY. That's how we would write it. That's shorthand of saying 2 things are congruent. Okay, well, what's the difference between congruence and equals? Equals is whenever we are comparing measurements. Okay? They have the same measure if they are equal. Typically, we compare these with numbers whenever we are talking about equals. Congruence is comparing geometric figures. Okay, so like line segments. We can compare them. They are congruent if they have the same length. So if they are equal, then they would end up being congruent because they have the same length, at least for a line segment. Okay, so one thing I do want to warn you guys. Congruence, you write like this, with the line over top. If you say equals, we would end up just leaving the line off. Remember, without the line, we're talking about a specific length. With the line, we are talking about a generic line segment. This is a line segment AB. As soon as we take that line off of it, we're talking about a specific length. Okay, so beware of that.